Okay, so today I'm going to go over Edexcel A-Level Mathematics, Paper 1, Pure Mathematics 1 from 2020. Okay, let's start. Question 1a. Find the first four terms in ascending powers of x of the binomial expansion of 1 plus 8x to the power of a half. Okay, so let me write this out. 1 plus 8x to the power of half. Okay, so all we need to do is implement the binomial expansion formula. So we will have 1 plus a half times 8x. Okay, that'll be a second term. And our third term will be 1/2 times minus a half over 2 factorial, okay, over 2 factorial times 8x, the whole thing squared, okay, plus a half times minus a half times minus 3 over 2 over 3 factorial times 8x cubed. Okay, so we'll just simply get 1 plus 4x minus 8x squared plus 32x cubed. Okay, part B. Explain how you could use x equals 1 over 32 in the expansion to find approximation for root 5. There is no need to carry out the calculation. So if x equals 1 over 32, okay, we can substitute x equals 1 over 32 into not the expansion, but just 1 plus 8x to the power of half. So if you just substitute that into 1 plus 8x to the power of a half, okay, then we'll get 1 plus 1 over 4 and the square root of that. So this is the square root of 5 over 4, which is root 5 over 2. Now, if we sub x equals 1 over 32 into our expansion, then we get another value, okay? And we're going to see what that value is. So if we substitute 1 over 32 into the expansion, we get 1145 over 1024. So we're saying that root 5 over 2 is equal to 1145 over 1024. So all we've done is sub x equals 1 over 32 into the expansion. And then once we do that, we can clearly see we have to multiply this value by 2 to get root 5. Okay, so sub into the expansion and then multiply by 2. Okay, that's all we have to do. So if we check what this is, that means that root 5 is approximately 1145 over 512, which is approximately 2.236. Okay. Question 2. By taking logarithms of both sides, solve the equation 4 to the power of 3p minus 1 is equal to 5 to the power of 210, giving the value of p to 1 decimal place. Okay, so 4 to the power of 3p minus 1 is equal to 5 to the power of 210. Okay, so if I take the log of both sides, I get 3p minus 1 log 4 is equal to 210 log 5. Now I could just do this in one step, but I'm going to do multiple steps. So I know that 3p minus 1 is equal to 210 log 5. Okay, 210 log 5 over log 4, because I divide both sides by log 4. So 3p is equal to 210 log 5 over log 4 plus 1. So P, if you divide both sides by 3, is equal to 210 log 5 over log 4 plus 1, and the entire thing divided by 3. Now we're going to need to use a calculator to do this. So we get 210 log 5 over log 4 plus 1 divided by 3, which is 81.6. So P is approximately 81.6. Okay, question 3. Relative to a fixed position O, the point A has a position vector 2i plus 5j minus 6k. Point B has position vector 3i minus 3j minus 4k. And point C has position vector 2i minus 16j plus 4k. Find the vector AB. Okay, so AB is simply going to be OB minus OA. So it's simply 3i minus 3j minus 4k minus 2i plus 5j minus 6k. Okay, and that's AB. So if you simplify this, 3i minus 2i is I, minus 3j minus 5j is minus 8j, and minus 4k, okay, so minus 4k minus 6k is equal to this is plus 2k. Minus 4k minus 6k is minus 4k plus 6k, so it's plus 2k, and that's AB. Okay, B, show that the quadrilateral OABC is a trapezium, giving reasons for your answer. Okay, so let's say this is position O, or vector O. We have A, B, and C. Then this is vector OB, vector OA, and OC. So we're asked to show that this is a trapezium. Now we know that AB is I minus 8j plus 2k. And we also know that OC is 2i minus 16j plus 4k. So since OC, the vector OC, is 2 times the vector AB, okay, and OA is parallel to BC, we know that OABC is a trapezium. And that's our reasoning for 2 marks. That's all we have to say. Okay, question 4. The function f is defined by f of x being equal to 3x minus 7 over x minus 2 for all real numbers x and where x is not equal to 2. Find f inverse of 7. Okay, so first we have to find the inverse. So let's say that y equals 3x minus 7 over x minus 2. Okay, so then we can swap x and y. So x is equal to 3y minus 7 over y minus 2. So if you multiply both sides by x and y minus 2, so you get xy minus 2x is equal to 3y minus 7. So xy minus 3y is equal to 2x minus 7. Okay, so now if you factorize, we get y times x minus 3 is equal to 2x minus 7. Okay, so we know that y is equal to 2x minus 7 over x minus 3. So f inverse of x is equal to 2x minus 7 over x minus 3. So now we just substitute 7. So we have 2 times 7 minus 7 over 7 minus 3. which is just 14 minus 7 over 4. So it's just 7 over 4. Okay, part B. Show that f of x is equal to ax plus b over x minus 3. Okay, so I'm just substituting in f into itself. So 3x minus 7 over x minus 2. Okay, that's the original f of x. So 3 times 3x minus 7 over x minus 2 minus 7 over x minus 2. And x again is just 3x minus 7 over x minus 2 minus 2. So I'm going to simplify this, so it becomes 3 times 3x minus 7 minus 7 times x minus 2 over 3x minus 7 minus 2 times x minus 2. So I get 9x minus 21 minus 7x plus 14. And I get at the bottom, I get x minus 3. So I'm left with 2x minus 7 over x minus 3. So a is equal to 2 and b is equal to minus 7. Okay. Question 5. A car has 6 forward gears. The fastest speed of the car in first gear is 28 kilometers per hour, and in sixth gear is 115 kilometers per hour. Given that the fastest speed of the car in successive gears is modeled by an arithmetic sequence, find the fastest speed of the car in its third gear. So for an arithmetic sequence, we know that an is equal to a plus n minus 1 times d. So we need to find what the common difference is. So first, we know that a is 28, and we know that n minus 1 is 5, because 6 minus 1 times d is 115. So we know that 5d is 115 minus 28, which is 87. So d must be equal to 17.4. Now to find the fastest speed in third gear, I can do a3 is equal to 28 plus 3 minus 1 times 17.4. Okay. So 34.8 plus 28, which is 62.8 kilometers per hour. Okay, 62.8 kilometers per hour. Okay, given that the fastest speed of the car in successive gears is modeled by a geometric sequence, find the fastest speed of the car in the fifth gear. Okay, so we know that an is equal to a r to the n minus 1. So again, a is 28, so 28 times r to the fifth power is 115. So r is the fifth root of 115 over 28. Okay, so r is 1.326 approximately. So if I do the fifth root of 115 over 28, I get 1.326. Yeah. So now I can either do just 28 times what our r was, 1.326, etc., to the power of 4. Okay, I can just do that. So time to the power of 4 multiplied by 28 to give me 86.7 kilometers per hour. Or I could also do, because I know what the fastest speed is in the sixth gear, I can also do 115 over r. Okay, 115 over 1.326, which would again give me 86.7 kilometers per hour. Okay. Question 6. A, express sine x plus 2 cos x in the form r sine x plus alpha, where r and alpha are constants, r is greater than 0, and alpha is between 0 and pi over 2. Give the exact value of r and give the exact value of radians, exact value of alpha and radians to 3 dp. Okay, so if I do this, let's go ahead and do this. So what is r of sine x plus alpha? Okay, so I'm going to do this a very long method, or the method that guarantees no mistakes. So this is r times. Now, if we know what the expansion of sine alpha x plus alpha is, it's good. So it's sine of x cosine alpha plus cosine of x times the sine of alpha. Okay, so now we know if we expand this out by multiplying by r, we have r sine x cosine of alpha plus r cosine of x sine of alpha. Okay, and this is equal to sine x plus 2 cosine x. Okay. So now I can compare them. So I can say that r sine x cosine alpha. Okay, I can say that r sine x cosine alpha is equal to sine x. Okay, and I can say that r times cosine of x sine alpha is equal to cosine of x. Okay, so if I say this, these two statements, then what I can do straight away is cancel out the sine x over here and the cosine x is over here, is to reach the conclusion that r cosine of alpha is equal to 1 and r sine of alpha is equal to 2. Okay, so if I do r sine alpha over r cos alpha, I just get tan alpha. So tan alpha is equal to 2. So alpha is equal to 1.107. Okay, so now I can try and find the value of r using Pythagoras, because r is just the square root of 1 squared plus 2 squared. So r is simply the square root of this, square root of 1 squared plus 2 squared. Okay, so r is equal to root 5. Okay, so I have root 5 sine x plus 1.107. And that's the answer to question 6a. Okay, 6b asks us to find the maximum temperature inside the room. Okay, so it says the temperature theta is modeled by this equation over here. So I can basically substitute what we know already to rewrite this model. Okay, so I have 5 plus root 5 sine. Now what happens is this term over here, pi t over 12 minus 3, is basically our x. Okay, so our x has just become pi t over 12 minus 3. Okay, so it's 5 plus root 5 sine pi t over 12. Okay, and minus 3, but we still have to add on the 1.107. We still have to add that on. Okay, now theta max is simply when this term is 1. So it simply is 5 plus root 5, or approximately 7.24 degrees Celsius. Okay, part C. Find the time of day when the maximum temperature occurs, giving your answer to the nearest minute. Okay, again, this is a fairly simple question. We basically just have to find the value of t, which produces 5 plus root 5. Now, if you haven't spotted this already, you can basically just solve this term, sine pi t over 12 minus 3 plus 1.107 is equal to 1. Okay, that's all we're going to have to end up doing, and I'll show you why. So let's say that 5 plus root 5 sine pi t over 12 minus, now I'm just going to rewrite what's inside the brackets by simplifying it. So I'm just going to say 5 plus root 5 sine of pi t over 12. Now, instead of writing this as minus 3 plus 1.107, I'm going to just say minus 1.893 is equal to 5 plus root 5, okay? Because when that's the maximum. So now, as you can probably see why I've said you can just solve this is equal to 1. Okay. So I'm basically saying you can just solve that this section over here, you can solve this equal to 1. That's what we're going to end up doing. Okay, so notice this. So if I subtract 5 from both sides, I'm left with root 5 sine pi t over 12 minus 1.893 is equal to root 5. So sine of pi t over 12 minus 1.893 is simply just 1, okay? And this is obviously true. It's obviously correct because when is sine maximum, right? It's maximum at 90, right? And sine of 90 is 1. So we're basically trying to figure out when this is equal to 1. Okay. Now I've already said it's 90. So if I do the sine inverse, I should get pi over 2 radians because we're working radians. So I should get pi t over 12 minus 1.893 is equal to pi over 2. Okay, so pi t is equal to, what was that equal to? It's equal to 1.893 plus pi over 2 times 12. So t is simply 12 over pi times pi over 2 plus 1.893. Okay, and you, again, use the calculator to do this. So 12 over pi multiplied by pi over 2 plus 1.893 gives you 13.23, which is 13:14 p.m. Okay. Now, question 7. Okay. Figure 1 shows a sketch of a curve C with equation y equals f of x and a straight line L. The curve C meets L at points 2, minus 13, and 0, 25. The shaded region R is bounded by C and L, as shown in figure 1. Given that f of x is a quadratic function in x, and minus 2, 13 is the minimum turning point of y equals f of x, okay? Use inequalities to define R. Okay, so first I'm going to go ahead and work out the equation of the line. So I'm going to write equation of line, because that's the first thing I'm going to work out. Okay, because that's usually very simple. So what's the gradient? The first thing I want to know what the gradient of the line is. So let's just say gradient. Okay, we know that's a change in y, but change in x. Okay, so, well, it goes from 13 to 25. So it goes 12 and then 0 minus 2, which is 2, so it's 6. So the equation of the line L is y equals 6x plus c. Now I can substitute in the values I have. Okay, so 13 is minus 12 plus c. So c is 25. So the equation of the line is simply y equals 6x plus 25. Okay, now to find the equation of the curve, well, I know that the turning point is at minus 2. So I'm assuming that the polynomial looks something like this. A times x plus 2 squared. And I'm going to write I'm going to write minus 13 over here, because it doesn't matter what value of a we have. Whenever x is 0 or when x is 0, we know that it has to go to minus 13. Okay. So now I can substitute the values of 0 and 25. So I'm going to now say that 25 is equal to 2 squared multiplied by a, so a times 2 squared minus 13. So 4a is 12, so a is 3. So c, curve c, is defined by 3 times x plus 2 squared minus 13. Okay, so now we have the equations for the curve and the line. We can start to define the region R by the inequalities. Okay, so what I'm going to do now is, sorry, this should be plus 13, not minus. Plus 13, because it's minus 2 plus 13, not minus. So that's, yeah, sorry about that, guys. This should be plus 13. Okay, so now we can clearly see that it's bounded between these two, okay? So it's always greater, okay? It's always greater than the curve, but less than the line. So it's bounded, okay, it's bounded above curve, okay, above C, curve C, and below line L. So we can say that 3 times x plus 2 squared plus 13 is less than y is less than 6x plus 25. And that is how we do this question. Okay, moving on. Question 8. A new smartphone was released by a company. The company monitored the total number of phones sold n at time t days. Okay, that makes sense as well. This company observed that during this time, right, the rate of increase n was proportional to n. Use this information to write down a suitable equation for n in terms of t. Well, now I think what they mean is it's proportional to t, because being proportional to itself doesn't make much sense. So I'm going to guess it means t. I'm guessing they mean t over here. So what I'm going to go ahead and do is I'm going to say that, well, n is equal to f of t, okay, because it's a function. And I know that dn by dt, which is the rate of change, is proportional. Oh, wait, no, hold on. Maybe it does mean n. Maybe it does mean n. Okay, this is fine. Okay, that does make sense. So n is a function in terms of time, and dn by dt is approximately n. So I can say that dn by dt could be equal to an. So if I did this by solving the differential equation, I would get that dn by dt, okay, dn by dt is ae to the kt. Okay, so that means that n equals e to the kt, and that is the answer. Okay. Question 9. Figure 2 shows a sketch of the curve C with equation y equals f of x, okay, where f of x equals 4 times x squared minus 2 times e to the minus 2x, okay, for all real values of x. Show that f dash x is 8 times 2 plus x minus x squared times e to the minus 2x. Because how would I even go about doing this question? Well, I know that I have this function f, but I can see that it's factorized. So the key thing to memorize is, for this question, is the product rule. We have to use the product rule. Okay, so now if you notice this, we have f of x is equal to 4 times x squared minus 2 times by e to the minus 2x. Okay, so if you wanted to work out the derivative, I would suggest using the product rule. Obviously, you could expand it out and then do it, but I'm just going to suggest that we use the product rule. Okay, so if we use the product rule, I'm just going to say that v of x is equal to, well, 4 times x squared minus 2. So 4x squared minus 8. Okay, and I'm going to say that k of x maybe is equal to e to the minus 2x. Now, what does the product rule state? The product rules, well, it states that simply that f dash of x is equal to v dash x times k of x, okay, plus v of x multiplied by k dash x. Okay, so now we could probably make it easier for ourselves and work out v dash and k dash. So v dash of x, well, what's that? It's the derivative of 4x squared minus 8, which is just 8x. Okay, and k dash x, well, that's equal to, if you bring the power down of e to the minus 2x, it's minus 2 times e to the minus 2x. Okay, so now we have v dash x and k dash x. Now we can use our formula. So f dash x is equal to 8x multiplied by k of x, which was e to the minus 2x, okay, plus 4x squared minus 8x, sorry, minus 8 multiplied by minus 2 times e to the minus 2x. Okay, now we can expand and simplify this. Okay, so what do we get? Well, 8x multiplied by e to the minus 2x is just 8x e to the minus 2x. Okay, now 4x squared multiplied by minus 2e to the minus 2x is minus 8x squared e to the minus 2x, and minus 8 times minus 2e to the minus 2x is 16e to the minus 2x. Okay, so we have 16e to the minus 2x. So now we can factorize. So I can see that 8e to the minus 2x is the common factor. So I'm going to take it out. So 8e to the minus 2x, okay, is, so I just have x in here, minus x squared, and plus 2. So now I'm almost done with the question. So this is just 8 times 2 plus x minus x squared times e to the minus 2x, which is what we had to show originally. Okay, part B. Well, what is part B? Hence, find in the simplest form the exact coordinates of the stationary points of C. So that's when this expression is equal to 0. So 8 times 2 plus x minus x squared multiplied by e to the minus 2x is equal to 0. That's what we're trying to solve. Okay, so this is basically the same as solving 2 plus x minus x squared is equal to 0. Okay, that's basically what we're going to end up doing in this question. So if you do that, then what do we get? So 2 plus x minus x squared is equal to 0, which means that we'll get x squared minus x minus 2 is equal to 0. So we get x minus 2 and x plus 1. Okay. So the x coordinates of the turning point are 2 and minus 1. Okay, so now what we have to do is simply substitute these values back into y equals f of x to get the y coordinates. That's it. So we can do this now. So if we have that, the formula, when x is 2, okay, we have y equals 4 times x squared minus 2. Well, x squared minus 2 is just 2, and e to the minus 4. So this is equal to 8e to the minus 4. And when x is equal to minus 1, y is equal to minus 4e squared. So the coordinates of the turning points are minus 1 minus 4e squared. Okay. And 2, and the y coordinate of that point will end up being 2, and the y coordinate will end up being 8e to the minus 4. Okay, so these are the two coordinates. These are the two coordinates of our stationary points. Okay, so then we can move on to part C. So part C, yeah. So now what we have to do is we are given that two functions, f of g and f of h, are defined. So, sorry, g of x and h of x. So g of x is 2 times f of x, and h of x is 2 times f of x minus 3. And we have to find the range of g and h. Okay, so part Ci, well, we know g of x is 2 times f of x. Okay, so in this case, okay, if we try and sketch the graph again carefully, I'm going to try and carefully draw what g of x looks like. So we had the coordinate axes, and we had looking something like this. I should bring it down, and yeah, so also notice that since we're doing 2 times f of x, the y coordinates will also be multiplied by 2. Okay, so this will look something like this. Coming down. Okay, maybe if I do it thinner, I can do it thinner. So to be more accurate, I should probably draw like this. Hold on, let me try and do it even better, so it's clear what I'm trying to do. This is just not working. Okay, you know what? Let me just try one last time. Maybe if I make my pencil thinner. So in one clean stroke, let's go for it. Oh, whatever. I'm just going back to the other one. You get the idea. You just have to read. All I'm trying to do is redraw this this graph, except multiplying all the y coordinates by 2. So it should end up looking something like this. Okay. And before how I said, remember how I said that everything's being multiplied by 2? So this turning point now isn't -1 minus 4e to the power of 2. It's -1 minus 8e to the power of 2. Okay. And the other point isn't 280 to the power of -4, it's 216e to the power of -4. Okay, because we just multiplied the y coordinates by 2. So the range in this case is g of x is greater than or equal to -8e to the power of 2. Okay, now for h of x, so CII, we'll have to do a similar thing. So in this case, we're doing the same thing, except also subtracting 3. Okay, so h of x is 2 times f of x minus 3. So what happens is, we know that the 16e to the -4 will just become 16e to the -4 minus 3. Okay, and when it comes to -8e squared, right, if you subtract 3, okay, we know that that wouldn't count because it's only for x is greater than or equal to 0. So we just have to figure out where the curve of h of x would intersect the x-axis. Okay, so that's all we have to do. So our graph now will look something like this. Okay, so our new graph would come up like in this manner. Okay, and yeah, so this was now 216e to the -4 minus 3. And all we have to do now is figure out where h of x is equal to 0. So let's go ahead and try and do that. So if I write h of x, so let's go ahead and try and find where it is equal to 0. So now, or rather try and find where where it's equal to 0. So I have that h of 0 is equal to 2 times f of 0 minus 3, which is simply equal to -19. So in this case, the range is simply -19 is less than or equal to y is less than or equal to, okay, it's less than or equal to 16e to the -4 minus 3. Okay, and we're done. That's how we do that question. Question 10a. Use the substitution x equals u squared plus 1 to show that the integral of 3 over x minus 1 times 3 plus 2 root x minus 1 between 10 and 5 is equal to this, where p and q are positive constants. Okay, so A, I'm told that x is equal to u squared plus 1. So dx by du is equal to 2u. So dx must be equal to 2u du. Okay. Okay, what else do we know? We can say that u squared is equal to x minus 1, and u therefore must be equal to root x minus 1. And yeah, let's say that x is equal to u squared plus 1. This helps us find what p and q are. So when we have 10, we know that 10 is equal to u squared plus 1. So u must be equal to 3, because we know the positive constants. And 5 is equal to u squared plus 1. So u must be equal to 2. Okay, now we can just use the substitution. So our new integral I is between 3 and 2. And now we have 3 times dx. Well, 3 times dx is 3 times 2u du. And this is over x minus 1. Okay, x minus 1 is u squared times 3 plus 2u. Okay, because u is just square root of x minus 1. So it's 3 plus 2u. So now if you cancel out the u and the u over here, this will become the integral between 3 and 2 of 6. Okay, 6 over u times 3 plus 2u dq. So p is 2 and q is 3. Okay. And now we have to find the value of a because we're integrating it. So part B, 6 over u times 3 plus 2u is equal to a over u plus b over 3 plus 2u. So now I'm going to say that 6 is equal to a times 3 plus 2u plus du. Okay, and now I'm going to say that when u is equal to minus 3 over 2, this will help us find b. So 6 is equal to minus 3 over 2b. Okay, so b is minus 4. And u equals equal to 0 helps us find a. So 6 is equal to 3a. So a is equal to 2. So now I can integrate it. So now I have integral between 3 and 2 of 2 over u minus 4 over 3 plus 2u du. Okay, so this term over here becomes 2 ln u. Okay, and minus, well, if we just had 1 over 3 plus 2u, we would just have a half. So if it was 1 over 3 plus 2u, okay, if we had, actually, let me explain it this way. If it was, so let's say, we know the derivative of d dx of ln of 3 plus 2u. If we took the derivative of that, okay, we would be left with, well, we'll be left with 2 over 3 plus 2u. Okay, except we want a minus 4, so we multiply this side by minus 2 as well. So we have minus 2 ln 3 plus 2u. Okay, and between 3 and 2. Okay, so we can also say that this is equal to 2 ln, okay, 2 ln u plus 3, sorry, u over 3 plus 2u between 3 and 2. So now, if I substituted in 3 and 2, then I would get 2 ln, okay, and 3 over 3 plus 2u, so it's 3 over 3 plus 2 times 3, so that's 1/3, minus 2 ln and 2 over 3 plus 2u, where u is 2, is 2/7. So we are left with 2 ln 1/3 minus 2 ln 2/7. And when we have subtraction with logarithms, we have to divide. Okay, so this is 2 ln 7/6. Okay, and now we can just square it. So ln of 49 over 36 is our answer. So A is 49 over 36. Okay, so now we can carry on with question 11. Circle C1 has equation x squared plus y squared is equal to 100. Circle C2 has equation x minus 15 plus y squared is equal to 40. The circles meet at points A and B as shown in figure 3. Show that angle AOB is 0.635 radians to 3 significant figures, where O is the origin. Okay, so let's try and do question A. So we have A, O, and B. So I'm just going to mark angle AOB. So this is the angle they want to find. Okay, and I can see us having to do some multiplication by 2 at some point by first finding what this angle over here is. So let's begin. First, I'm going to try and find coordinates of A and B. So I'm going to say that y squared is 100 minus x squared. And then I'm going to use this as part of the substitution to find x. So x minus 15 squared, okay, plus 100 minus x squared, because this is y squared, is equal to 40. So now I'm going to say that x squared minus 30x plus 225 plus 100 minus x squared is equal to 40. So 30x, okay, 30x is equal to 285. So x is equal to 9.5, or rather, I can say 19 over 2. Okay, so we can now re-substitute to find y, and y is, you would get that y is equal to 39 over 2. So now what we can do is we can say that since these are circles, I can say the coordinates of A are 9.5 root 39 over 2. Okay, and the coordinates of B are 9.5 minus root 39 over 2. Okay, so now we have the coordinates of A and B, and we're trying to find angle AOB. Okay, so what I can do now straight away is see that OA is 10, and I know that the distance of the x coordinates from O to A is 9.5. Okay, because A has coordinate 9.5. So I can say that, or even I could even say that, yes, so I can say it's 9.5. So I have this triangle. So I have the angle is unknown, and I have 9.5. I'm going to call this alpha. So I'm going to say that cos alpha is 0.95 because 9.5 of 10. So alpha is 0.317 ... So therefore angle AOB must be 2 times that. So it's 0.635, which is what we wanted. Okay, that's what we wanted. So now part C, or even part B rather, not part C. Part B is where we have to find out what the perimeter is of the shaded region enclosed by circles C1 and C2. Okay, which is slightly more lengthy to do. Okay, but just remember, arc length is the key formula. So arc length is r theta. Okay, that's the key formula to find the arc length. And this is what we're going to use mainly in this question. So now I'm just going to extract some information. So I know that this O to the midpoint, I'm going to call this M, is 15. Actually, let me just draw it this way. I'm just going to draw what I have. So this is kind of what we have. Kind of like a diamond shape. Okay. So I'm going to call this O. I'm going to call this M because that was the midpoint of the circle, or the center of the circle. So I had O, A, and B. And I'm just going to call this C instead of M. I'm going to call this C. So I know that OA is 10, and I know that OB is 10. And I know this distance, okay, from O to wherever A is 9.5. Okay. And what do I have to figure out? I need to figure out what, first of all, I need to figure out what this angle is outside. So to find what the angle is, I'm going to do 2 pi minus 0.635. Okay, is the obtuse angle which is outside. Okay, this obtuse angle, theta is what we need to find the arc length. Okay, I'm going to call this equal to theta. Okay, and similarly, I'm going to have to do the same thing for the obtuse angle on the other side. Okay, which I'm just going to call, for sake of ease, I'm just going to call this phi. Or even just use the symbol for phi. So I can easily figure out what theta is. So theta is 2 pi minus 0.635. Okay, so 2 pi minus 0.635, which was 5.648. Okay, so 5.648 radians. And now I can figure out what our theta is. So that was 56.48. Now I have to do the same thing for the other side. So now I'm going to figure out what these angles are, or rather what this angle is. This was alpha. I'm going to call this beta. So we know that this length over here is 15 because it's from 0 to C, C being the center. OC is 15. And O to M, I'm going to call this M, is 9.5. So MC must be equal to 5.5. Okay, MC must be equal to 5.5. So now I have this triangle over here, 5.5, and the other side, which was, what was it? 2 root 10. Okay, root 40, 2 root 10. Okay, now what I can do is I can figure out what this angle will be. I'm going to call this angle X. So X is going to be the cos inverse of 5.5 over root 10, sorry, over 2 root 10, which is equal to, let's check what this is equal to, cos inverse of 5.5 over 2 root 10, which is equal to 0.516. And I know that beta is equal to 2x. So if I multiply this by 2, that will be the value of beta. So 1.0327. And I know now that phi, the angle phi, is 2 pi minus beta. Okay, which is equal to 5.25 dot dot dot. So R phi is equal to 2 root 10 multiplied by this number. Okay, which is 33.206. So now the perimeter P is equal to 56.48 plus 33.206. And to 3 decimal places or 3 significant figures, this is equal to 89.7. Okay, 89.7. And that's how we do this question. Again, it's a question of being able to see patterns. And obviously, by the end of it, you'll be comfortable with doing questions like this. Okay. Question 12, part A, show that this expression is equal to this expression. Cosec theta minus sine theta is equal to cos theta cot theta. So I'm going to write cosec theta as 1 over cos theta. And then, sorry, 1 over sine theta. And then you just have minus sine theta. So this is just 1 minus sine squared theta over sine of theta, which is equal to cosine squared theta over sine of theta, which is the same as cosine of theta multiplied by the cosine of theta over the sine of theta, which is equal to cosine theta cot theta. Okay, and that's how we do this question. Part B, hence or otherwise solve for x. Cosec x minus sine x is cos x cot 3x minus 50. Okay, so cosec x minus cot x is equal to, sorry, cosec x minus sine x. Okay, cosec x minus sine x is equal to cos x cot 3x minus 50. Cos x cot 3x minus 50, and we have to solve for x. Okay, now this is a fairly tricky question. So first, what we're going to do is rewrite this as cos x cot theta. So cos x cot x is equal to cos x cot 3x minus 50. Okay. Now something to realize is you can bring everything to one side and factorize by cosine. Okay, so cos x cot x minus cos x cot 3x minus 50 is equal to 0. Okay, so I can factorize out the cos x. So if I take out cos x, I'll have cos x times cot x minus cot 3x minus 50 is equal to 0. Okay, so now I'm going to try and solve this for x. So this means that cos x is 0, or cot x, okay, cot x is equal to cot 3x minus 50. Okay, so now cos x equals 0 is just gives me x is equal to 90 degrees. Okay, now the tricky part is being able to solve this equation. Cot x is equal to cot 3x minus 50. Okay, that is a tricky part of the question. So now what I can do is use my knowledge of trig identities to solve this question. Okay, so if I do know that cos x is cot 3x minus 50, then what can I say? Well, let me just write this again. Cot x, okay, is equal to cot 3x minus 50. So this means that x is simply equal to 3x minus 50. Okay, so 2x is equal to 50. So x is 25 degrees. But there's also a third value, okay, a third value in this whole thing. Okay, and to find the third value, we're going to have to use some more trig knowledge. Okay, so if I do say that one value is 25, then I also know that another value is simply going to be 180, sorry, not 180, 180n plus 3x minus 50. So if I solve this now, okay, I can solve it now. Then I will get when n is 1, sorry, when n is equal to 0, I know that x is equal to 3x minus 50. However, when n is 1, okay, this is when n is 0. When I say n is 0, I mean that, so I simply mean that one value is given to me already, so I can find the other value, n and n. That's all I mean. So what I could do is, we know one value of x. Okay, so this is when n is 0. So what I mean by that is to find the next value. Supposing we convert back to, if you just think about cot theta, cot x being equal to 1 over tan x. Okay. Then we also know that the next values will just be 180n plus 3x minus 50. Okay, so what I mean by this is if I have n is equal to 0, all I've done is said that I've said that it's equal to 25, okay, which is fine. What happens if I say n is equal to 1? Okay, when n is 1, x is simply equal to 180 plus 3x minus 50. Okay, which would lead to me saying that 2x is equal to, well, it's equal to minus 230, sorry, minus 130, which would mean that x is minus 65, which is not something we want. So let's try n is equal to minus 1. Well, when n is equal to minus 1, then what happens is we have x is equal to 100 minus 180 plus 3x minus 50. Okay, so we get that 2x is equal to 230. So x is equal to 115. Okay, so we have 90 degrees, 25 degrees, and 115 degrees. To be completely honest, I don't think I've explained this that well, but it is pretty difficult to explain because it is a pretty tricky question. But if you guys don't understand it, then just comment in the comment section and I'll try and explain it separately. Okay. Question 13. A sequence of numbers a1, a2, a3 is defined by an plus 1 is equal to k times an plus 2 over an. Okay, where k is a constant. Now we're also told that the sequence is a periodic sequence of order 3 and a1 is equal to 2. So now we basically have to show that k squared plus k minus 2 is equal to 0. So now what we can do is first find the full values, the first full value. So a1 is equal to 2. Okay. a2, well, what's that? It's k times 2 plus 2 over 2. Okay, which is just 2k. Okay. Then we also know that a3, okay, a3 is k times a2 plus 2 over a2. Okay, so let me write this out. A3 is k times 2k plus 2 over 2, which is just equal to k times k plus 1, and a4 is equal to k times wait, no, k plus, sorry, this should be 2k. Okay, this should be 2k over here. So it's equal to k plus 1. Yeah, that was my mistake. A4 is equal to k plus 1, or rather k times k plus 1 plus 2 over k plus 1. Okay, which is equal to k times k plus 3 of k plus 1. Okay, so it's equal to k times k plus 3 of k plus 1. So now we can try and solve this question properly. Okay, so if we go ahead and do this, we also know that it's periodic. Okay, so we know that 2 is equal to k times k plus 3 over k plus 1. So we know that 2 is equal to k times k plus 3 over k plus 1. Okay, this is periodic. So 2k plus 2 is equal to k squared plus 3k. So k squared plus k minus 2 is equal to 0. Okay, and we showed that that's true. For the sequence, explain why k cannot be equal to 1. Okay, so we obviously have to think about what happens when k is equal to 1. So let's see. Well, what happens when k is equal to 1? If k is equal to 1, then a1 is 2. Okay. Then a2 would be, let's see, 2. A3 would be equal to 2. And a4 would also be equal to, well, 2 as well. So we can say that if k is equal to 1, all the terms would have the same value. Okay, would have the same value. So it wouldn't be periodic. That's basically what we can say. So if they're not all the same, it could be periodic, but since all of the values when k is 1 are equal to 2, we can say it wouldn't be periodic. Okay. And that's our reasoning for why it can't be equal to 1. Then part C, find the value of the sum from R is 1 to 80 of AR. Okay, this is again it's an easy question if you're comfortable with doing questions on sequences and series. Otherwise, it's a bit tricky, even with the sigma notation and everything. But if you practice, obviously, you should be comfortable and fine with doing this question. Okay, so we know that k is equal to -2 is the only solution. Okay, k is equal to -2 is the only solution. So now what can we do to find the sum? Well, what we could do is basically, we can basically figure out how we can do this question. So A1 is still 2, okay? And we know that A2 is equal to -4, okay? We know that A3 is gonna be equal to, what's A3? A3 is keeps 1, so A3 is 3, okay? Sorry, -1, okay, hold on now. Yeah, so 2k, okay, 2k. So k is equal to -2. So it will be -4. Yeah, it would be -4. Okay, so then A3 would be -2 plus 1. So just -1. Okay, and A4 would end up being -2 times -2 plus 1. Okay, -2 plus 1 is just -1. Okay, so -2 times -2 plus 3. What am I saying? -2 times -2 plus 3 is -2, and that's over -2 plus 1. So it will be 2. Okay, so these are our first 4 terms. So the sum of the first 4 terms, A1 plus A2 plus A3 plus A4, is what we can calculate. So 2 minus 4 minus 1 plus 2 is -1. And because it's periodic, it's repeated every 4 terms. So we can say that's equal to sorry, not minus. What am I saying? A1 is equal to 2, A2 is equal to 3, and A3 is equal to -1. So A1 plus A2 plus A3 is what we have to calculate, which is equal to 2 minus 4, okay, which is -2, and -2 minus 3, which again is weird because it's giving me a negative answer. So what have I done wrong? Let me just think about what I've done wrong. Oh yeah, so the first 3 terms we've got. So what can I do to figure out what it is? Well, sum from 1 to 80. Well, this is a bit confusing now. So I get a different value from what everyone's getting. Sorry, what I've got before. But I don't think it should be equal to it. So this is minus How many times is it repeated? Well, let's see. Oh, okay, no, I figured out what I have to do. So what I do have to do is I have to realize that 2 minus 4 and minus 1, okay, are the first three terms. And how many times are they going to repeat it? So these are three terms. Okay, and what's 80 over 3 is equal to 26 and 2/3. So it will be repeated 26 repetitions. Okay, 26 repetitions. And then I'll have 2 and minus 4. Okay, so 26 lots of A1 plus A2 plus A3 minus 2. Okay, so 26 times A1 plus A2 plus A3, where A1 is 2. So 2 minus 4 minus 1 times 26. Okay, minus 2. So minus 78 minus 2, which is equal to minus 80. Okay, so that is a sum. Okay, let's carry on. Question 14. A large spherical ball is deflating. At time t seconds, the balloon has radius r and volume v centimeter cubed. The volume of the ball is modeled at a decreasing at constant rate. Using this model, show that dr by dt is equal to minus k over r squared, where k is a positive constant. Okay, so we're going to have to use our knowledge of differential equations to solve this question, which isn't difficult. Okay, you just have to be careful about how you lay this question out. Okay, so how would we go and do this? First, I'm going to say that the volume of a sphere is 4/3 pi r cubed. So dv by dr is 4 pi r squared. That's the first thing I'm going to say. Now, what else can I do? It's disgusting writing. B equals 4/3 pi r cubed. So dv by dr is 4 pi r squared. Okay, that's much more clear to see. Now we do know that the differential is, sorry, that rate is negative, it's decreasing, it's deflating. So I can say, for example, that dv by dt is minus a constant. So let's say c, minus c. Now I need to show dr by dt. So dr by dt is simply equal to dr by dv multiplied by dv by dt. Okay, so now dr by dv is just 1 over dv by dr. So it's 1 over 4 pi r squared times minus c. So this is dr by dt. Okay, dr by dt, which is minus c over 4 pi r squared. Okay, and we just say that it's, I'm not sure how we're meant to lay this out in terms of, okay, no, I can just say, which is equal to minus k over r squared. So I'm basically saying that c, okay, which is the constant. So I can also complete it by saying minus c over 4 pi, or c over 4 pi is k. Or no, hold on. What am I saying? This is how you'd show it. Part B, given that the initial radius of the balloon is 40 centimeters, after 5 seconds, the radius of the balloon is 20 centimeters, and the volume of the balloon continues to decrease at a constant rate until the balloon is empty. Solve the differential equation to find a complete equation linking R and T. Okay, so what I'm going to do now is I'm going to say that dr by dt is equal to minus k over r squared. So the integral of r squared dr is minus the integral of k dt. So 1/3 r cubed is equal to minus kt plus c, or not even c, kt plus, let's say, alpha. Okay, so now I'm going to say that when t is 0, r is 40. So r is 40, so 1/3 of 40 cubed is equal to hold on, r is 40 and t is 0. It's just alpha. Okay, yeah, so alpha. So alpha is equal to 64,000 over 3. Okay, and now we can figure out what the value of k is. So when t is 5, okay, the radius is equal to 20. So 1/3 of 20 cubed, okay, 1/3 of 20 cubed is equal to the value of 5k, or rather minus 5k plus 64,000 over 3. Okay, so 5k is equal to, well, what's that equal to? 64,000 over 3 minus 1/3 of 20 cubed, okay, which is 56,000 over 3. Okay, 56,000 over 3. So k is equal to this divided by 5, which is 11,200 over 3. Okay, so now I can finally say that I've solved the differential equation, right? And I can lay it out neatly. So now I can say that 1/3 r cubed, okay, is equal to minus 11,200 over 3 plus 64,000 over 3. Okay, so r cubed is equal to 64,000 over 3 minus 11,200. Sorry, not over 3. This shouldn't be over 3. R cubed is 64,000, okay, minus 11,200 t. Okay, so now part C, find the limitation of the values of t for which the equation in part B is invalid. So this basically means solve it equal to 0. So part C wants us to be able to solve this equal to 0. So I can just say that 64,000 is equal to 11,200 t. So t is equal to, let's see, 64,000 over 11,200, 40 over 7. So time is equal to 40 over 7. That's when it's invalid. Okay. It's very important to state this. Okay. Question 15. The curve C has equation x squared tan y is equal to 9. Show that dy by dx is equal to minus 18x over x to the 4th power plus 81. Okay, so now this is a case of being able to do implicit differentiation. So what we can do is we can have, okay, I'm just going a, so x squared tan y is equal to 9. So by using the rules of implicit differentiation, I'm going to say that 2x tan y, okay, plus x squared. Now the derivative of tan y is sec y, so x squared sec y, okay, dy dx, okay, is equal to, sorry, sec squared y is equal to 0. So now I also know that sec squared, okay, sec squared of y is equal to 1 plus tan squared of y, okay. I'm going to use this fact to solve it. So now what I can say is, well, what's tan squared y? Well, you might be thinking, well, I have no idea. But what we can do is, if I had this equation, I can always substitute it back in. So what this means is, if I wanted to do it, I have to do something like this. I have 2x tan y plus x squared sec squared y dy by dx is equal to 0. Okay, so now what I'm going to say is, for example, if I wanted to find dy by dx on its own, I have to do some extra steps. So I can say that tan y is equal to 9 over x squared, okay? And tan squared y is therefore 81 over x to the 4th power. And I can also say that if I wanted to, I can always rearrange it. So this is what I have so far. I have that this is equal to 0. So I just need to find out what my sec squared y is. So sec squared y is equal to 1 plus 81 over x to the 4th power, which is x to the 4th power plus 81 over x to the 4th power. Now I can substitute it back into this equation. So 2x times tan y. Tan y is 9 over x squared. So 2x times 9 over x squared, okay, plus x squared times x to the 4 plus 81 over x to the 4 dy by dx is equal to 0. Now we can simplify this. So 2x times 9 over x squared is 18 over x. So I have 18 over x. Now, this term over here, okay, the x squared times x to the 4 over x to the 4. Okay, now this just becomes an x to the 4. Okay. So this becomes x to the 4. So I will now have, actually, if I rearranged it, I could just solve it in one go. So dy by dx is equal to, what's this equal to? So it's equal to 2, or even minus, it's minus 2x times 9 over x squared over x squared times 1 plus 81 over x to the 4th power. Okay, which is equal to minus 18x, sorry, minus 18 over x over x squared plus 81 over x squared, which is equal to minus 18x over x to the 4 plus 81. Okay, we finally shown that it's true. Okay, part B. Part B is to prove that C has a point of inflection at x equals the fourth root of 27. Okay, now we know what dy by dx is, and we need to figure out what d2y by dx is. d2y by dx squared. d2y by dx squared, we're going to have to use the quotient rule, is equal to minus 18 times 4, sorry, x to the 4. Okay, minus 18 times x to the 4 plus 81. Okay, minus 18x times 4x cubed. Okay, over x to the 4th power plus 81, the whole thing squared. So now I'm going to have to simplify this in a very particular manner, which would allow me to show that it's true. So I'll get minus 18 times x to the 4th power plus 81. Okay, now minus 18x. So that's plus 18x. So plus 72 x to the 4th power. Okay, and at the bottom, I will have x to the 4 plus 81, the whole thing squared. So now I'm going to see if I can simplify anything even further. Let's just check if I can. So minus 18 x to the 4th power plus 72 x to the 4th power is 54 x to the 4th power. Okay, and minus 18 times 81. Okay, I want to know what that is minus 1458. So minus 1458 over x to the 4 plus 81 squared. Now I'm going to see if I can factor out the 54. So I think I can have 54 times x to the 4th power. Now if I try and divide this by 54, okay, I should get minus 27. So minus 27 over x to the 4th power plus 81 squared. Okay, I'm going to set this equal to 0. So x to the 4th power is equal to 27. Okay, so if I solve this now, I can just get x is equal to the 4th root of 27. Okay, so I can also prove this. I can say that when x is equal to 4 root 27, sorry, 4th root of 27, okay, I can say that d2y by dx squared is equal to 0. Then I have to say that when x is greater than the 4th root of 27, okay, then d2y by dx squared, okay, d2y by dx squared is greater than 0. And when x is less than the 4th root of 27, okay, then d2y by dx squared is less than 0, which means that it's a point of inflection. So I can say x equals 4th root of 27 gives a point of inflection. Okay. And that's how you do this question. Inflection. Okay, that's fine. And the last question, prove by contradiction that there are no positive integers p and q such that 4p squared minus q squared is equal to 25. Okay, so first you have to assume the opposite. Assume there are positive integers. Okay, there are positive integers, P and Q such that it's true. Then we have to find some sort of way to contradict our statement. But let's see how we go about doing this. Okay, such that 4p squared minus q squared is equal to 25. Okay, so the first thing you can notice is that our thing, it's a difference of two squares. So I can have 2p plus q and 2p minus q is equal to 25. That's one thing to immediately notice. So if this is true, then either 2p plus q equals 25 and 2p minus q is equal to 1, or both of them are equal to 5. 2p plus q is equal to 5 and 2p minus q is equal to 5. Okay, so now what happens when you do this? Well, let's see. So let's try and solve these both pairs of simultaneous equations. So let's solve, I'm going to call this equation A and equation B. So solve A, what happens? So if we do this, right, if we subtract them, I get 2q is equal to 24, which means that q is equal to 12, but p is simply 6.5. Okay, now if I solve B, okay, if I solve B, then I get 2q is equal to 10. Sorry, 2q is equal to 10. No, hold on. What am I subtracting? 2p plus 5, q is 5, and 2p minus q is 5. Or is it, hold on. I think I might have done something wrong. 2p plus q and 2p minus q. Sorry, 4p, this should be 4p. So 4p is equal to 10. So p is equal to 2.5 and q is equal to 0. So this has shown us that it's true. So we can say this is a contradiction. So we can say this is a contradiction. Okay. As there are no integer solutions. Okay. There's no integer solutions. Okay. And we've proved it. So this is also something you could show. This symbol. This means contradiction. So QED, we've proved it. And that's the end of the paper. It took a long time because I'm doing this purely on an editing site. Hopefully I can get something which helps me write better. But that's the end of the question. And yeah, I will try and upload something physics related next, so you can see what I'm doing right now on that. Okay.